I'm also inform you that before you selecting the data set, you also select the feature. Okay. So what do you mean by the feature? First, you understand what do you mean by the feature. The feature is individual observations that are analyzed into the set of quantifiable properties which are called as a feature. Okay. So these are the individual observations. Okay. So when you are trying to develop any data set, so in that data set, that observation, your observation, so that may be of vary person to person. Okay. So if I considering the example of a used car, so let us consider, I'm just considering the feature of car like this, how old of that car, how many years how that car has brought. Okay. So it may be a 10 year, it may be 8 year. Okay. And mileage of car. Okay. Then also I'm considering the color of car. Okay. And his current insurance. So before deciding the price, before deciding the price of the car, I just consider only these 4 features, and on the basis of these only 4 features, I will give the prediction of the used car price. Okay, so it is depend on my observation, but somewhere maybe different people have a different observation about how to decide the used car price. So he can use a different feature. So he may decide the location of the car also. You can take as a feature in this decision. Okay, so different type of feature you can add in your data set that totally depend on your individual observation. Okay, so let us consider the categorical. So let us consider one blood group data set. If you want to create a blood group data set, so what kind of blood group you have to maintain? So you have to maintain. You have to make the category of blood group like A category, B category, AB category, or O category. So these are categorical data you have to maintain. Then ordinal data. So if the height of student is large, medium, or small, or weight of the student is large, medium, or small. Okay, so you can keep them in ordinal format. Okay, so these are the integer value and the real value. So these features you have to keep in your mind while you are selecting the data set for your algorithm or for your machine learning algorithm. So proper feature selection is also important for the implementing the machine learning algorithm. So let us consider this example. In this example, there is some attribute. Okay. So what are the attributes? What are the features we are considering here? The action, the author, the trade, the length, and the where. So that's such type of data you have, and you want to find out the new example. You want to find out the action. So if that action is a skip or it is a read, right? So you can to predict this information, you require the feature, for example, action, author, thread, and the length and the where. Training algorithm, this is a normal supervised machine learning architecture, or you can say that how the supervised machine learning algorithm is work. So this is a very basic workflow diagram I would like to say about the supervised machine learning algorithm. So what exactly it works? So for working the machine learning algorithm, supervised machine learning algorithm, you require some training data set. Then you have to use the different learning algorithm, okay, and the hypothesis. In the next slide, what is the hypothesis? So all these three come under the component that is called the training. The first, you require to train your algorithm. So how you train the algorithm? For training purpose, you require the training data set. To train that data set, you must require a machine learning algorithm, and before that, you require some hypothesis. Okay. So if you don't have any target of your data, so what is the use of your that data? So from that data, what you want to find out? I want to find out that the student is pass or fail. So this is my hypothesis. So my hypothesis is that if the student having the less than, if the student having the mark less than 25, So he is failed, definitely failed. So this is my hypothesis 1, otherwise hypothesis 2. Yes. The hypothesis 2 is say that the hypothesis 1 is failed. Okay, or not true. So before implementing any machine learning algorithm, you must have some hypothesis of your problem definition. So my problem definition here, so in our previous example we have seen that from that student's marks data set, what you want to find out? I want to find out that if the students have the mark less than 25, the student is definitely failed. So this is my hypothesis. So to train you to make this hypothesis true, what you have to do, I am taking the one data set. So as we already seen that data set, that is called the training data set. And on the training data set, we are used some machine learning algorithm. Okay, so you can either say that you can take any learning algorithm. So that may be any supervised machine learning algorithm or unsupervised machine learning algorithm or anything. So first you require the training data set, then select the proper feature. Okay, that feature must be useful for your that is related to your hypothesis only. Okay, so you have to keep only those features in your data set. Then select the proper machine learning algorithm and then check that training data set and learning hypothesis, how they can satisfy your hypothesis. Okay, so training data set and learning algorithm, how they can satisfy your hypothesis. Okay, so this is a diagrammatic representation of machine learning algorithm. So you are giving the testing data and you are getting the predicting data based on your hypothesis. So you must have the one hypothesis. So in our previous example, in this example, okay, I took one hypothesis that if the student having the mark less than 28, so he definitely less than, I am telling that if the student having the mark less than 28, so he come under the category, that category is the fail category. Because if you see that FF, that is the I3 and I4, they having the mark 20 and 24, he is having the mark 23. So on the basis of that, I am taking only this hypothesis. It is not true yet. Okay, so that's why it is called as a hypothesis. So my hypothesis says that if the student having the mark less than 28, so definitely he will come under the category, and that category is called as the fail category. So this is my hypothesis. So to prove this hypothesis, what we require, you require the data set. That data set is called as a training data set. So that whole data set is called as a training data set. Any machine learning algorithm, okay, you can select any machine learning algorithm, and what is your hypothesis. So my hypothesis says that it is like this. So then and then you can give a prediction. Okay, so you can use this prediction that the student having a less than 28 mark, so he will has the prediction y is equal to fail. So this is my working of learning algorithm, machine learning algorithm. Okay. So I hope all of you now understand how the machine learning algorithm are work. So any doubt? Anybody? If there is no question, so we will move forward. Now, the next topic is feature space. So what is that the feature space? The feature space is, we already see that what is that feature. The features are the observed value. So whatever the observed value you are selecting in your data set, okay. So in previous example, when we considering the data set for the used car, so my observation are different, your observation will be different, the third person observation will be the different for considering the price of the car. So if you want to decide the price of the used car, so in that condition, what you have to do, you have to use your own feature. So you are select maybe one feature, two feature or three feature or any number of feature you can select while taking any decision. So let us consider I am taking here the two features. Okay, what my feature? So there is a positive value and there is a negative value. So these are the two my features. Okay, so the categories are maybe positive, other category might either be negative. Okay, so these are the two features I am selecting here. Now, if you consider this value, so this value is come under the 0.5. Okay, if this value is located at the 0.5 and the 2.8. Okay, so now what is the feature space? How you can give the testing point? Now you can see that in the previous example I trained my model and I am getting this some of the output. Okay, so it show that there are some value, that is a plus value, and there is some negative value, right? So you can mark out location of each point, positive point and the negative point. So for example, on the top of left hand side you can see that I am considering the one and it is located at 0.5 and 2.8. Okay, so you can take any value or x and y coordination. Okay, but let us consider I have this new value for testing. Okay, so what is that question mark? So you can see in the diagram there are the 4 question marks. Okay, so now my question is that these question marks are come under the positive category or come under the negative category. So how we can decide that these 4 question marks are come under the positive category or negative category? So before that, you have to take one decision, that feature space. Okay. So this feature space, how we can create a feature space? I am using the simple one solution. I am making the one line here and say that what are the label on the top upper side, they are positive, and what are the label that are lower upper side are the negative. Okay, there may be some you can decide the error. Okay, but that is the minimum error, right? So using this line, you definitely say that what are the question mark, they are belonging to the upper right corner, they are belonging to the positive, and a negative a lower one. Okay, so this is called as hypothesis. Okay, so this feature space, I am making the one space here, my features. Okay, so first understand what is my feature. So in my example, there are the 2 features I am considering. Which feature? Positive and negative. Okay, these are I call as a feature. Now when I enter the new feature here, now I want to find out these 4 data points are come under the positive feature or negative feature. So how we can be divided them into the positive and negative. So as it is come under the classification, so what I am doing here, I am using the simple one line here and say that what are the label upper right corner, since up to the 2.25 on the x-axis and 3.0 on the y-axis. So these are come under the positive, and the lower one, that is called as a negative label. So this line is called as a hypothesis. Okay, this line is called as a hypothesis. So the definition of hypothesis space is say that the hypothesis space used by the machine learning system is the set of all legal hypotheses that might possibly return by it. It is typically defined by the hypothesis language. Okay, just a minute. It's typically defined by the hypothesis and possibly by the conjunction with the bias. Okay, and it is denoted by capital H. So hypothesis space is always denoted by the capital H, where it is saying to the H belonging to the small h is belonging to the capital H, where the capital is the set of all the hypotheses and the small h is the output of learning algorithm. So you can select a number of hypotheses. You can decide the number of hypotheses for your data set. Okay, but out of that number of hypotheses, that is a set of hypotheses, only one hypothesis will be a true. Okay, now in my previous example, I said that the student having the less than 28 marks if the student having the less than 20 marks, so he is failed. So this is my first hypothesis. Now, my second hypothesis say that if student having a less than mark 25, he will be the fail. This is my second hypothesis. My third hypothesis say that if student having the less than mark 23, he will be the fail. So this is my third hypothesis. So out of this, so this hypothesis 1, hypothesis 2, hypothesis 3. So these are called as a set of the hypothesis. So I take a number of hypotheses, I decide the number of hypotheses on my data set. So that set of hypotheses is called as a hypothesis space. Okay, but out of that hypothesis, only one hypothesis will be true, and you can say that is the output of your learning algorithm. So either the student having the less than 23 marks, those are fail, or the student having the less than mark 25, those are fail, or student having the less mark 28 than the 28 are the fail. So in previous example, we have taken only the one value. Okay, so we can take it either 28 or 25 or 23. So you have to check the change the values, okay, and find out which hypothesis is correct. So either hypothesis 1 is correct, or either hypothesis 2 is correct, or either hypothesis 3 is correct. So out of this hypothesis, only one hypothesis will be, you can say that output of your learning algorithm. Okay, so this is called as a hypothesis space. The hypothesis space is, see, this line I already dropped in previous slide. So this line is called as a hypothesis line, or you can say as a function. A hypothesis space. This space is called as a hypothesis space. So either you can see that you can take a different hypothesis. So there is H1, H2, and H3. So I am taking the 3 hypotheses here, and somewhere that point is a common. Okay, and that common space is called the hypothesis space. So when you draw this line, okay, so these are the H1, these are the H2, and these are the H3. So out of these 3 lines, okay, either one hypothesis is true, this is a one fact, and then there is some value that must be shared by all these 3 hypotheses, and that value or that space is called as a hypothesis space. Okay. So this is all about the hypothesis and the feature space. Okay. If you have any doubts, you can ask me now.